Welcome to DesignSpark, the home of DesignSpark PCB, free award-winning electronics design software. PCB setup and placing components. Continuing our project, we now start to lay out the components of our PCB. Just to recap, we translate our schematic to PCB following the steps in the wizard. I am selecting to define layers for the rest of the tutorial and choose a 2-layer board with a paste mask for the surface mount components and also a solder mask for the top and bottom sides. I leave all the other settings at their default values, and we now have a typical arrangement for a manufactured PCB. I leave the PCB shape as rectangular at the default sizes, as we can easily customize these later. Here we have our generated PCB outline with all of our component footprints and interconnections. The interconnections shown in yellow are often referred to as a rat's nest. Beginners often ask how to turn these off, but leave these visible as they are a helpful feature showing the density of connections between components, which will help with the component placing for a successful layout. Launch the interaction bar by the shortcut key F9. This will help with component identification and placement. It is also useful for many other purposes, as shown in the list, such as errors, nets, styles, unrouted connections, etc. Good PCB design is a combination of many factors. We will not discuss good PCB design in this tutorial, but it is generally good practice to keep the components grouped together as their schematic function. So we will frequently refer back and forth between the schematic sheets and the PCB for the component groups. Here on sheet 2 we have the D to A and op amps, so let's place them first. We can select a component from the interaction bar by simply highlighting it, as I have done here for U2. It can then be dragged and dropped to place onto the PCB. We can also select the component directly and place as required. Selecting U1 is a good example of how the rat's nest of interconnections shows the density of the tracks that will result. Looking at the schematic, we can see IC1 has the connector J1 associated with it, and we can place this and rotate components with the shortcut key R. Placing IC1, we see the rat's nest of wires to the capacitors, and using a selection box these can all be selected and placed together. Similarly, we can select the LEDs and their current limiting resistors as a group and move and rotate them as required. The remaining components are then placed on the board. We now have our initial component placement, and we can move specific components for their best position. First we look at the capacitor associated with IC1. As we move C6 around, we see the interconnections jump between the nearest connection points. We can rotate the component for the best track options, so even though non-polarized, there could be a better orientation for shorter tracks, etc. We repeat this for C5, C1 and C2. The LEDs and their resistors are next addressed. And this process is repeated for all the components until we're happy with the basic layout. Now we examine the design technology file. Use Shift+T to launch. Select the Layers tab. We can see all of the layers and can edit their colours and also order to match a typical PCB construction cross-section. Here you see my ordered layers. Documentation. This does not form part of the construction, but can be used to record notes and manufacturing instructions. Top paste mask is used when we have surface mount components and is used for tooling. Now we have our actual PCB with the typical layers. Silk screen for component outlines, references, polarity marks. Solder mask. This is the solder resist layer, which helps to define the solder areas, which is particularly useful for fine pitch and surface mount components. Copper layers are our copper tracks, component pads, vias, heatsink areas, etc. Should your layer order not be in a desired order, simply left click to select, and we use the up and down buttons to reorder. You can also change the layer colours, again by selecting and then choosing from the pull down menu. On the Track Styles tab, we can set our track widths for the defined styles, and we can add our own track styles using the Add Style button. We will leave the settings at their defaults. The Nets tab lists every net in our design and the assigned net class. We can edit the entries for any net to signal, power or ground. These assignments are used in the PCB tracking stage, so it is worth taking the time to edit the entries. The pad styles can similarly be edited. These will normally be left at their default values. However, it is often worth editing the drill hole size to the size supported by your PCB manufacturer. Text styles and line styles can be left at their default values, as can the layers types, but are all available for editing should there be a requirement. The Spacings tab is worth investigating, as it is likely we will edit the entries. Check your PCB manufacturer's requirements for minimum cost options, as small spacing and track widths can attract a premium charge. Also, do not go smaller than necessary, as this can make troubleshooting and assembly more difficult. Entries are edited by selecting and overtyping with new values. The Rules tab also allows other PCB limits to be set as required, but again these are left at their defaults. Now save all our changes by clicking on the OK button. We will now introduce the Design Rules check. This can be used at any stage of our PCB design and provides a useful indication of potential problem areas requiring further design effort. Launch the Design Rules check from Tools on the menu bar. Here we have a window with the options to select for checking. With just the board and components selected, running a check produces our report without any errors. Moving a component onto the board edge and running the Design Rules check reports the error. The interaction bar, which is launched by the shortcut key F9 if not already open, is very useful while correcting Design Rules errors. With the Go To tab active, choose Errors from the pull down menu, and in this case we see our single error. Clicking the coordinates centralizes the reported error for correction. Restoring our layout, we now demonstrate online Design Rules check, which is often referred to as a real-time Design Rules check. From Tools on the menu bar, select the Online DRC option. Now in real time, as we attempt to place the component in an illegal location, we are presented with an error message, giving the options to continue or not. With the Online Design Rules check disabled, I showed a situation with multiple errors. Here I place two components on the edge of the board, and the Design Rules check reports shows 7 errors. These are 5 pads to board errors and 2 for the component to board errors. These are also listed in the interaction bar. To see each error location, simply click the coordinates and the window has centralized the error, which helps enormously in finding the location and allowing changes. The error text on the board can be cleared at any time using the Delete Errors button. That completes our initial component placement, and in the next video we will show the PCB routing processes. Thank you. Brought to you by RS and Allied Electronics.